Namaskar, hello and a very warm welcome to this special webinar series of ours, Listening to Learn. मैं हूं तन्वी खुराना। इस वक्त आप हमें देख रहे हैं ई विद्या चैनल नंबर 9, 10, 11 और 12 पे। Department of Education in Science and Mathematics NCERT brings you this program, this National Student Outreach Program, that is प्रवासी भारतीय Academic and Scientific संपर्क, जो कि इंटीग्रेट करता है इंडियन डायस्पोरा को अपने मदरलैंड से। आप कहीं पे भी हैं, दुनिया में कहीं पे भी बैठे हैं, इस वक्त हमारे साथ इस कार्यक्रम का हिस्सा बन सकते हैं, जुड़ सकते हैं, अपनी बातचीत रख सकते हैं। कोई सवाल है तो भी हमसे पूछ सकते हैं। अपनी बातचीत रखिए। और इस वक्त आप हमें देख रहे हैं हमारे YouTube चैनल पर, जो कि है NCERT ऑफिशियल। उसके लाइव चैट बॉक्स में आप अपने सवाल लिखिए और हम तक ज़रूर पहुँचाइए। Let me tell you the topic for today. It's a very important and interesting topic, and that is aircraft accidents and black box, जिसे हम हिंदी में कहेंगे हवाई जहाज दुर्घटनाएं और ब्लैक बॉक्स। आप सभी ने एयरक्राफ्ट एक्सीडेंट्स के बारे में सुना होगा। पैसेंजर क्रैशिंग एयरक्राफ्ट्स जो होते हैं अक्सर हम सुनते हैं, एंड देयर इज समथिंग अबाउट देयर ब्लैक बॉक्स। व्हाई इज दैट ब्लैक बॉक्स सो इम्पॉर्टेंट, एंड व्हाट इज द रोल ऑफ दैट ब्लैक बॉक्स? देयर इज अ लॉट टू know about that black box and its importance, and about those aircraft accidents. Why do they happen? So there are so many things that we are going to talk about in this particular program. Please raise your questions and we'll be expecting your questions in next 1 hour. ये कोई आम प्रोग्राम नहीं है। इट्स बिन लास्ट 2 years, मोर देन लास्ट 2 years, जब हम ये प्रोग्राम आपके लिए लेकर आते हैं, और कुछ ऐसे टॉपिक्स पे डिस्कशन होती है जो यूनिक होती हैं, आउट ऑफ द बॉक्स होती हैं, दे आर डिफरेंट देन यूजुअल। सो अगर आपके पास भी कोई ऐसा टॉपिक है, चाहते हैं हम इस प्रोग्राम में आपके टॉपिक्स लें, तो आप हमसे प्लीज़ बात कीजिए। आप अपने सवाल हम तक पहुँचा सकते हैं और टॉपिक्स भी हम तक पहुँचा सकते हैं। Let me please introduce you to the brain of this entire program. We have with us Dr. Gagan Gupta. Sir, a very warm welcome.
Namaskar, Tanvi.
Namaskar. Sir needs no introduction at all. He is the reason why we are sitting here today, and he is the reason why this entire program has been such a success. So along with him, let me please welcome our guest for today, and he is Dr. Menak Ghosh Hajra. Sir, a very warm welcome.
Thank you.
So I would request Dr. Gagan Gupta to please introduce the topic, introduce our expert to all our viewers, and let me just
Thank you, Tanvi. दिल्ली आज बहुत खुशनुमा है। स्मॉग यहाँ से जो पॉल्यूशन की स्मॉग की लेयर बनी हुई थी, वो आज ऊपर वाले की दुआ से आज बारिश हुई है काफ़ी अच्छी, और हम लोग एक बहुत अच्छे मौसम में हैं दोस्तों। आज बहुत अच्छा मौसम, दिल्ली बहुत अच्छा लग रहा है, और आज इस अच्छे मौसम में एक बहुत अच्छे व्यक्ति के साथ और एक बहुत अच्छे टॉपिक पर हम बात करने आए हैं। दोस्तों, आपको याद होगा कि ये प्रोग्राम हमारा अगस्त 2021 में शुरू हुआ, लगभग 2.5 साल हो चुके हैं, और आज का हमारा सत्र लगभग 66वां सेशन है, और हम इस सेशन में आगे बढ़ते चले जा रहे हैं। आप लोगों के सुझाव हमें बहुत मदद कर रहे हैं। आज का भी जो सेशन है वो आपकी डिमांड पर है दोस्तों। मेरे पास कई सारे ईमेल्स और टेलीफोन कॉल्स आए, जिसमें कि उन्होंने कहा कि सर एक सेशन FDR और CVRs पर होना चाहिए। आज हम आपकी मांग पूरी कर पा रहे हैं, थोड़ा देर से ही सही, लेकिन हम आपके पास ला पा रहे हैं। हम धन्यवाद करते हैं काउंसिल ऑफ साइंटिफिक एंड इंडस्ट्रियल रिसर्च हेडक्वार्टर्स न्यू दिल्ली का, जो कि हमारे साथ इस प्रोग्राम में एक तो कोलैबोरेटर भी हैं, और आज के एक्सपर्ट भी जो मेरे साथ हैं वो CSIR की ही एक प्रयोगशाला नेशनल एरोस्पेस लेबोरेटरीज से आए हैं, और जिनका की तारुफ मैं कराऊंगा अभी आप लोगों के साथ। दोस्तों, हमने इस प्रोग्राम में एविएशन के ऊपर काफ़ी प्रोग्राम किए हैं, काफ़ी बात किया। आप याद कीजिए, अक्टूबर 2022 में पिछले साल हमारे साथ देवोपम दास आए थे IIT कानपुर से, जिन्होंने कि हमें बताया बेसिक फ्लूइड मैकेनिक्स, एरोस्पेस की एयरक्राफ्ट की बेसिक फ्लूइड मैकेनिक्स के ऊपर हमने चर्चा की थी। अभी थोड़े दिनों पहले ही हमने एविएशन मेट्रोलॉजी 20 अक्टूबर 2023 को ही हमने एविएशन मेट्रोलॉजी पर बात की थी, जिसमें कि एक एविएशन इंडियन एयरफोर्स के ही एक्सपर्ट हमारे साथ थे, राजीव महाजन। आप इन सारे सेशंस को आप हमारे NCERT वेबसाइट के इवेंट सेक्शन में जाकर के देख सकते हैं। वहाँ पर ये सारे सेशंस हैं, और साथ साथ NCERT ऑफिशियल पर भी ये सारे प्रोग्राम आपको मिल जाएंगे। एक बार फिर से मैं आपको धन्यवाद देता हूं CSIR का, काउंसिल ऑफ साइंटिफिक एंड इंडस्ट्रियल रिसर्च, साथ साथ में नेशनल एरोस्पेस लेबोरेटरीज। आज के प्रोग्राम में दोस्तों जितने भी कई सारे आपको पिक्चर्स देखने को मिलेंगी, ये सब ऑलमोस्ट ओपन सोर्सेज से ली हुई हैं। हम उन सारे सोर्सेज के, उन सारे रेफरेंसेस को धन्यवाद भी देते हैं कि उन्होंने हमें परमिशन दी है और हम उनको रेफरेंस देते हैं, उनको एक्नॉलेज करते हैं। NCERT भी एक्नॉलेज करता है और साथ साथ CSIR की नेशनल एरोस्पेस लेबोरेटरीज भी उनको, उन सभी सोर्सेज को एक्नॉलेज करते हैं। आज का प्रोग्राम बहुत ही एक रोमांचित करने वाला होने वाला है, मुझे मालूम है, जिसमें कि हम हवाई जहाज़ की बात करेंगे। इतने अच्छे मौसम में आज हम हवाई जहाज़ की बात करेंगे दोस्तों। तो जैसा कि मेरी साथी तन्वी ने आपको बताया कि फ़्लाइट डाटा रिकॉर्डर्स एंड CVRs, इनको कि हम ब्लैक बॉक्स कहते हैं, ये ब्लैक होते हैं नहीं होते हैं, बहुत सारे सवाल हमारे बच्चों के और हमारे मस्तिष्क में आते हैं। हाउ डू दे वर्क, हम इस पर बहुत गहनता से चर्चा करेंगे। मेरे साथ मेरे यंग दोस्त, एक यंग मैन इज़ विद अस टुडे, मयंक घोष हाजरा। ही इज़ ए ग्रेजुएट फ्रॉम वेस्ट बंगाल टेक्निकल यूनिवर्सिटी इन इलेक्ट्रॉनिक्स एंड टेलीकम्युनिकेशन इंजीनियरिंग, एंड ही इज़ ए पोस्ट ग्रेजुएट फ्रॉम इंडियन इंस्टीट्यूट ऑफ टेक्नोलॉजी खड़गपुर, and then he is presently associated with the Council of Scientific and Industrial Research, National Aerospace Laboratory, Bengaluru. He is a flight operational quality assurance FOQA analyst, a safety critical avionics system designer and masters in wireless, that is in 4G and 5G communication systems. His professional career spans more than 17 years in missile communication technologies, flight operation analysis, and in safety critical embedded system designs. Manak is an avionics integrator for Federal Aviation Regulations, that is FAR 23 and 25 class of aircrafts. Friends, these aircrafts are weighing more than 5,700 kgs, more than 5.5 tons. Manak is a member of Aeronautical Society of India, Aeronautical Radio Incorporated ARINC, and Society of Automotive Engineers SAE International. Dr. Manak has received multiple awards like Best Project Execution Awards, Design Awards, etc. for his distinguished contribution in aerospace industries. Prior to joining CSIR NAL in 2008, Dr. Manak has been associated with the Defense Research and Development Research Organization DRDO at Chandipur. Manak is an avid music and art lover. He greatly enjoys different cultural connections. Friends, children, you can visit these laboratories sometime. I am sure that CSIR NAL will be happy in making you to visit their laboratories to a great extent. Please either contact to CSIR NAL directly or contact to NCERT. We will manage your trips to NAL and any other laboratory which you want to visit across India in CSIR system or in DST system. You can contact us, we can take you along. And of course the ISRO laboratories as well, because we have a collaboration, a strong collaboration with the Indian Space Research Organization. You can visit their laboratories with us or we can manage all those things. So Manak, once again I welcome you. Thank you very much for coming to the studio, and we would love to listen you. And once again I thank CSIR NAL for collaborating with NCERT for the purpose. So it's all yours, Manak. Yes.
I want to thank you, sir, for giving me the opportunity to speak here and bring my personal experience and professional experience to the students and the educators. So here today's topic is aircraft investigation and black box. And before telling about this, I just want to introduce little bit about our organization, that is National Aerospace Laboratory. We are a sister laboratory of a Council of Scientific and Industrial Research, which is more than we have 1960s the NL started in Bangalore, and we are specializes in aircraft design development for civil and defense industries. Lot of technologies has emerged. So one of the important activities what we do at NL is we develop a flight operational quality assurance software which reads the black box data. From there this experience comes. More than 20 years has been spent on this. Also we does a material characterization, crack detection, fatigue analysis of an aircraft structure. I am going to tell little bit hint on during the course of the lecture. So let us start here. So here if you see the recorder I have kept very left is a black box. The black box is a very intriguing words. Everybody asks what is black box, what is black box. Black box is primarily a data recorder which records the data for a different aircraft parameters. But is it really black? It is actually not. The black box is painted international orange. Now why the name black box? There are two theories behind it. Theory number one, at the earlier generation this data was stored in a tape, and when you are writing data in presence of any light, that particular data could have been destroyed. So that would have been a complete seal. So from there black word came. The second theory what it came is during Second World War, the British people who actually use this kind of recorders in an aircraft, their aircraft doesn't want it to be taken by the German counterpart. So they painted all the boxes are black. So in that scenario this came. So there are two theories prevailing for calling it as a black box. But as you know this black box is mainly orange. So keep this in mind. And so we have, if you see what we have shown here is an Australian scientist Dr. David Warren. He is the inventor of this box. So what happened during his childhood, his father passed away in an air accident. From there he started nourishing that he has to find what happens in an aircraft. So he became an engineer, he became a scientist. Then he tried to develop this box which records the parameter. So first black box looks like this circular type, is a prototype. So then this, if you visit down, we have given links for everything. There is Australian laboratory online also available, lot of data available about the history of the black box which you can see, which is Australian Powerhouse Museum. So before understanding the black box, let us understand an aircraft little bit. An aircraft has different surfaces, it has different systems. So mainly I will talk about the surface because next part onwards we will refer few of the surfaces for few cases. So it gives you a flaps, it gives you aileron, it gives you rudder, it gives you slat, elevator, everything. Whereas flaps are high lift device. So there are ailerons which generates rolling motions. There are rudder. Please note this rudder, this will be the point of interest from the next 2-3 slides, which control the position of the nose of the aircraft. So in case of rudder or elevator, anything failure, controlling aircrafts becomes very, very difficult by the pilots. So we will talk about a particular incident which is called American Airlines Flight 587, which happened on 2001 November 12, just immediately after 8/11 you can tell. So aircraft took off from John F. Kennedy Airport, and after going up immediately the aircraft crashed. So 60 people just dropped out of the sky from the aircraft. So it is very peculiar because normally there was nothing, just it took off and the aircraft crashed. So what happened? So let us see, this is the this is the airport. From there it was doing a circular motion, and during one part this is a vertical stabilizer which is this part got shifted off out of the aircraft, and immediately aircraft crashed here. So this became a very peculiar accident. So what happened? So there was a CVR transcript. CVR means Cockpit Voice Recorder. So how the analysis works we are going to explain here. So what we understand from the CVR analysis, that suddenly after 9:15 there was a main attachment fitting fracture in 9:15:58. So the sound of the loud bang came. So the aircraft, the stabilizer got out of the aircraft. So this done a CVR analysis transcript that can this kind of lab. There is a FDR analysis of all the parameters, which is done like this. When after recovery of the data, you have to take out the memory chip and put it, and then there is an accident report. So what investigator concluded at the end of it is that this is not a terrorist attack, because first they understood it is a terrorist, and next what happens, it is decided after this analysis it is not at all a terrorist, it is purely a pilot fault. How the pilot fault we will see in the next slide. See so normally what happens after reading the data, they present in a simulation environment like this kind of, where the engine data, there will be audio data are shown. So you can see left side, these are called CAM, means cockpit area microphone. In cockpit area microphone, it has heard the sound of 2 thumbs and then immediately light bang. So the aircraft suddenly started. So the actual scenario can be replicated back in our investigation data. You can see there is a rudder paddle which was showing exactly at 9:15:53, but at 9:16 there is no data available. So FDR data or flight recorder data gives you the size of insight of an accident, and you can literally bring out the anomaly, what has happened, how it happened. Now what happens after finding this, what we should do? We have to find next stage, that how to analyze the data. So these are the data which has taken from a FDR, different surface positions, and we can see at the end when this after 9:16, there is a lot of disturbance on every side, and the plane lost control within 10 seconds. So the last 10 to 15 seconds data becomes a great importance for the investigators who wants to understand why this aircraft crashes. So you can see what happened, which is very unique actually in this scenario. This aircraft took off and it was doing a heading turn. In front of that there was a big Boeing 747 aircraft was there, which is very big. So due to that, the generating motions out of the aircraft create a disturbance for this aircraft flying. So the pilot told, so we can see left side, so the pilot wanted to increase the power, so that is a hot mic told. So the co-pilot actually tried to increases rudder paddle more, the right rudder paddle, which the surface was not able to sustain, so it crashed. It purely the pilot understanding of the situation. So these kind of greater details is only possible if you have a FDR CVR combined analysis. Without that, this analysis is not possible. So that's why it has become very important tool, or the main part for aircraft accident analysis and investigation. So now here we are showing some of the major accidents in India, which is like Kanishka bombing, Arabian Sea crash, and very famous is in the Mangalore airport, where due to airport the entire aircraft ditched into a small narrow area, claiming 158 lives. So, the details you can go into the Wikipedia and see. So these all analysis reports available, I think, in DGCA websites also. So it may be of interest to few of you. So how there are, now you understand, these investigations are done by lot of people, but the data are very confidential. So the data cannot be shared because it contains the flight critical data, it contains the internal dynamics of the aircraft, it contains personal information about what has been talked. So it cannot be shared across with anybody. So there are always an authorities per country who are deciding factor. For India, it is called DGCA, Director General of Civil Aviation. They have the full authority and control over it. For USA, it is NTSB. Like Europe, Australia, all we have listed here. So what does investigators do? They try to determine the facts, they try to determine the conditions, and what are the circumstances relating to an accident, like Boeing 747 aircraft leading to this particular case. And they also issue safety recommendations. So what recommendation you should do so that further this scenario doesn't happen. So there are different kind of classes available, investigation classes, which is class 1 to 4. Normally class 1 deals with the transport category, and class 2 to 4 is little bit advanced, where a lot of involvements are required for multi agencies. So this gives you a latest one, which whatever we have shown earlier is little bit of older. This gives the latest informations, where 2021, this is available in Flight Radar website, where the aircraft which has fallen into an accident got replayed back. Here the issue is that many of the data are missing from the FDR. but still we were able to show in this tool that how the radar forces are happen. So, the tool plays a very important role here. It creates, it generates a dynamics, it creates the data from a supporting data. So, if there are the supporting data available, from there you can create the main parameters. So, there is a dependency can be created from the main to sub parameters and can be shown to the investigators that what happens, how it happens. The same thing we have gone to little bit of details of how it shows. You can see here left side, this aircraft, this is a Kozhikode airport, another incident. It came out, do a circling and went back. So, this normally what happens, you are not able to, you are approaching an airport, but if you are not able to land, if you are not in a particular speed, particular angle. So, there is something called misapproach. So, you do a misapproach if your speed is high and again come back. So, here the green one is called first approach, yellow one is a second approach, and still the accident happened because the aircraft was not able to land into a particular angle. So, and see if you can see right side, at each section of an airport there is a requirement of a ground speed. So, whenever aircraft comes into that particular landing, they have to maintain that. If they cannot, then they either have to fly or there may be a cause of accident. So, that these are the parameters which investigators or the analysis person looks into it and find out why this has happened, why he is not able to reduce the ground speed, why he is not able to align the aircraft in a particular direction, why the headings are not proper. So, all these things are very important tool of deciding that my aircraft is in correct path or not. So, what we have shown here, after all this analysis, there are reports to be generated by the agencies, which is a summary of all the things happened. So, there are three major part. One is called factual informations, that means what has been connected, the entire like history, injuries, damage, personal, the entire data collection. Next part is the scope, what investigators do, and third is the entrance safety recommendations. So, once these three forms the basis of it. So, right side what you have shown here, this is actually taken from a Airverse, it is called FDR parameter library. So, this is little advanced, do not go into the details of it. What we wanted to tell here is, these are the all parameters get mapped after we do a FOCA analysis and we generate all this data. So, here is the flight recorder means not only FDR, it is FDR, CVR or any other recorders. So, this data is one of the sample, you can go down, there is a link, and this also an investigation civil aircrafts is actually contains passengers. So, passenger is the main important factor. So, in case some passengers are status after the accident need to be recorded. So, this is the one sample how investigation authorities does, who are demised, who are critical, who are actually safe. So, just to bring you how they do, we have brought this thing. So, after all these things, we just wanted to know what flight recorders does. This is still now how the accident does. Now, we will discuss about what is the scope of flight recorders, and apart from accident there are some more applications. The same thing we are going to see here. So, at initial days, so this has started kind of 1960s, where one jetliner crashes in storm in India with 40 on board. This was a Douglas this H-160 Comet aircraft. From there what they started, they have employed an early generation of the flight recorder. So, which writes into metal foil. So, if you see the technical term of FDR, it is called foil oscillographic recorder. It is not FDR, the technical term is called foil. So, you are writing into a foil in a oscillations mode. So, what happens during next course, the technology changes, it becomes a flight recorder. The earlier generation first one was writing into a metal foil, and from there only the oscillations you used to see. Still you can see this oscillation in a digital form. So, the same thing has been explained here. So, this is the some older generation flight recorders are shown where there is a metal foil present. So, it moves the foil 6 inch per hour during. So, you have a 200 feet, so equivalent to 400 hours of footage can be recorded in the particular flight recorder. So, you have a metal recorder and it measures altitude and space. This is this data available in open source YouTube, you can go, there is a detailed video on it, you will be able to understand the each one what happens. This is also a flight recorder has to be thermally very safe. That means in case of fire and in case of any other accident, the recorder has to save himself. So, there is a specific material has been developed that is called incolel, which is a super alloy, and once you heat it up, it creates an protective oxide layer which gives you the inherent protection from a fire. The flight radar recorder history means the 1970s or this time there was a tape based recorder. That means we used to write data into a tape, and the tape, magnetic tape, is then recovered. Then there was a laboratory, there you can put this tape back, replay it, decode it and generate that. Nowadays that became a 1990 onwards, it is called solid states FDR, flight data recorder, which you can write inside in a digital form, and you can this data is posted into, like, this is the location of normally in the back, which is the most safest part of aircraft. In case of landing, this is by the study it has shown that this area becomes the most safe. So, the recorders will be there. So, you can see an actual photo of a flight data recorder in CVR in an aircraft. So, at today, as today there is a little advance from this also. Nowadays we call it combi recorder. Combi means CVR and FDR merged into a single recorder. So, that is the technology running today. So, the CVR recording is as right side shows, it is purely a cockpit. See, cockpit mic, pilot mic, then there is a cockpit headphones. Then you can see 4 channels get recorded. So, the regulation is 2 hours we need to record, and subsequently more you can record, but 2 hour slots. So, this is the last 2 hours of the cockpit which can be erased by the pilot if there is no space. So, that control is given shown in this picture with a bigger. So, pilots get an access to a ground control push button switch. So, after 2 hours over you can erase and put a new one, in between that will be downloaded by the ground engineer, and you can test a CVR functionality. The similar way there is called FDR event push button. Let us say pilot is when flying, he understood there is some engines out came. So, he wants to record it. So, what he will do, he will press this event push button and that will be marked. So, that event markers helps the investigation or the routine analysis to finding what kind of event has happened, to trace the events. So, black box does a multifunctionality. So, at there is some 5 classes we have shown here. So, that is called mandatory flight data, that means to investigate or do accident analysis. So, mandatory flight data is like 88 parameters are available from a FAR guideline. So, FAR 23 guideline is there, and there is also an ASA guideline in DGCA that is called CAR guideline. So, that has to be there part of FDR and CVR, whereas there is a supplemental flight data which mainly used for aircraft flight performance. That means, the routine analysis of the flight data which efficiently increases the flight data characteristics, the analysis, and how the aircraft should uses less fuel, more effective, less cost. So, that is the primary onus of this OEMs who are like Air India, you have a Vistara, this kind of airlines will mainly look for this extra data. Then there is a cockpit voice which gets recorded. Then there is a data link which is very interesting, because till now we have not come into this word of data link. So, what does data link means? Data link means is a digital packet data transfer through a satellite link between multiple aircraft to aircraft. So, in between you can see an AVAX, this is a, you can think as a DRDO the AVAX, which has a airborne communication controller, which gets connected to satellite connectivity, which connects to multiple fleets, which connects to tanker and ground station. So, whatever data gets connected between all these also get recorded in a data link message. So, that also gets recorded, we can decode it and put it. So, there is normally a separate recorder available as a data link recorder, and also there is a optional in few aircrafts you have a images and videos recorder. So, cockpit image gets recorded, outside video or environments get recorded. So, that also can be used for as a augmented analysis platform. In total, the entire things is not accident, incident, it is called SMS, that means safety management system, that is called aircraft. So, this SMS comprise of end to end, that in flight data capture, data acquisition in one hardware, converting the data into a specialized packet form which can be read via or written or read via your in FDR or CVR. Mainly this is the FDME used for FDR. Then there will be wireless ground link, which once the aircraft lands into an aircraft, it does a parking brake, it opens the door for passengers coming out. Immediately this data get transferred to the hangar where this FOCA analysis station will be there. Through the network link that is available within 10 minutes all over the world, where you can do a post processing. So, you can understand with this advanced mechanism, you can literally analysis the entire thing, and the aircraft once it goes back to hangar, you know the status of the aircraft. So, you know this aircraft is safe to fly or not, this aircraft can you take into the next sortie or not, which brings a special interest to the one group that is called MRO group, which is called management, repair, overhauling. This is specifically aircraft industries, which makes sure the aircraft continuously runs and the aircraft maintenance cost becomes very less. So, for airport authorities, for engineers, aeronautical society engineers, for aircraft supply chain, this MRO is very, very important, and these data that looks into it, the aircraft should not go down, otherwise the profit will go down, cost will go down, go up. So, what happens to do this? There is a little bit delta work is there, that is called QAR, that is called quick access recorder. So, this data gets transferred into a QAR and that gets transferred just for informations. So, left side what you can see, there is a recovered black box from a site which is damaged. So, so we have shown here there are two sections, one is the processing section which is the signal acquisition, and here is the your memory which is covered multi-layer protected, so that high impact fire and everything it does not get impact to the memory chip. And also there will be this front one is called ULB, underwater locator beacon. That means when the impact happens, this unit goes under the sea or it goes under the water, it starts emitting a beacon for it is a distress signal or locator signal where you know what is there. So, this is up to 20,000 feet it works, and right side if you can see it works, operational environment is minus 55 degree to 71 degree, but it has a fire protection of 1100 degree Celsius for 60 minutes, so it can survive that. So, it is really made for harsh condition, so that it retains the data. So, what happens, let us say if you have got a fully destroyed recorder, you bring out the chip, the chip then gets taken out via specialized lab, this then you put back into a specialized device to decode the data. This also a little earlier 10 years back generation, today's technology again got changed, but you will get a summary how this works. So, this we have already talked, these 88 mandatory parameters which are available part of the regulations which to be downloaded into an FDR. So, now we come to a different context of a FDR usage which is called routine monitoring. Routine monitoring means it is not accident investigation, the entire data, the performance of the aircraft to be monitored. So, always the supplementary data uses us. So, initially at 1960 this data was like 10, 15 to 25 max data, where today for Airbus 380 or Boeing 787 it came up to 1400 parameters nearly. That means, all this data used for a performance analysis. And if you use this data, what happens? Let us say we have given an example of Alaska Airlines, you can literally know what is the passenger load factor, are you using the full aircraft or not, what is the loss you are doing in per aircraft, is passenger capacity is correct, and this devise a very unique decision which every day if you are flying you will come to know. You will suddenly see today's I have came yesterday saw in one aircraft they have reduced the bathroom space, they have reduced the entire basin size to half. Why? Because that with that you can use the bathroom, but you can add 6 people in the aircraft. So, what happens? Your revenue goes up, you can maintain more, you can get a more profit out of it. So, this kind of data, the usage data, statistics data all can be taken from this, and here you will see machine learning and AI plays a major role on it to bring out the anomalies, to bring out the advantages, to bring out all the profits what you can take from the FDR data. So, this is the FOCA software which we had developed at NAL. So, I have just given a paper for a reference. So, left side if you can see there is a .bin file, means that is a output. You can see it is flown from Delhi to Mumbai. There is a 40 sectors, 40 times it has flown. The data got captured, event got analyzed, then we have plotted, and right side reports are there for India. So, different accidents. So, this is one of the summary how you can analyze an aircraft platform. So, there are some advanced topics which you need to know if you are using a flight data analysis and FOCA. So, so comes to the machine learning part of it. So, you get a flight data, you do a pre-processing, and you create a matrix, multiple side matrix. Here the target is to reduce the anomalies. You can, due to the recorders, you will have a multiple anomaly of data. So, that has to be first taken out. So, there are different machine learning algorithms part of it. So, here what they normally use a nearest neighbor algorithm, and they detect the flight anomalies. They do the threshold anomaly, and they do post processing, and again I have shown the same example. You can generate this kind of data, and you can find out what is the batch you are interested. You cannot process everything, you have to process a certain segment of it. That this kind of analysis gives you that data. And also this tells you a very interesting factor using this kind of analysis, in which phase of the flight the maximum accident occurs. So, what you have seen with this kind of analysis, that final approach and landing gives you 54% of an accident, whereas the fatalities also 40%. So, this is the most of importance to us for a airport. So, what does airport starts giving upgraded with a advanced navigation aids and advanced radio aids, which helps the pilot to land it in a bit safer way. So, the upgradation of the facilities of avionics also defines by this analysis, that which part of an aircraft should be upgraded to accidents are less, which part of the airport or the facilities to be upgraded. So, all you can analyze through this machine learning models and AI from output of this FOCA, means the FDR data, and data link messages plays very important role here. And also here there are 10 parameters mainly concentrate here as per the machine learning and all, which can give you a tentative idea what happens. So, what do you do? That is called vehicle health monitoring. So, you continuously monitor. Now, to augment this analysis, you put some more hardwares in the aircraft itself, not only FDR, which particularly analyze this in real time. And once you integrate that data with FDR, it becomes IVHM, which is integrated vehicle health monitoring. So, with this you can literally get the feel of it, and you can do a predictive maintenance. You know, okay, when this aircraft is going to fail, your structure health, if your structure is done for another maybe 30 flights, your system can run maybe another 20 flights when is bound to fail. So, literally you can prevent the accident. So, that is the new technology, people are researching on it, on IVHM, and there will be a, once this is technology is proven, we hope that accidents will be much less, much reduced factor. So, when you are doing a FOCA analysis, you literally need to know few terminologies if you want to research. One is anomaly detection, one is neural network, one is different methods of active machine learning, and different kind of classifiers to be designed to make sure you do analysis properly. So, here we have bought some advanced configuration for routine monitoring. This is just for a show that okay, this kind of advanced softwares are available today for all kind of analysis. So, you can literally show a entire cockpit in a PC environment, play the data and see exactly what happened with the airport model. So, you can actually see the airports also. Just do not confuse this with Microsoft Flight Simulator. Flight Simulator data are not validated. It can bring the data into a open source data which is not validated. These data sets are cleared by the authorities from internationally. This is a valid data. So, there is a data difference between flight data simulators open source and for FOCA same, and you can see the actual terrain data, actual chart, all these things are available part of the latest flight data analysis package. And just one more thing is like we can do an event analysis where there will be a severity, there will be a normal path is 3-degree path angle which is glide slope, there is severity 1, there is severity 1, 2, 3. 3 means severe, that you should not have done, there is a chance of accident that you are crossing the threshold. So, this is the event which gets configured part of FOCA configuration, and also you can segregate the FOCA in a multiple data set in multiple slots. So, each slot you can do analysis and you find the nearest which is gives the less error prone. So, you stage by stage by the multiple machine learning you take out the false data and bring out a valid class of classifiers. In the classifier once you focus you get the actual data. So, this just giving the different kind of thresholds. This already we have gone, only what we wanted to add here is there is a data format inside FDR which can record a 64, 128, 256, 1024 words, each is 12 bit like this. So, there will be a subframe which is 4 seconds, 4 subframe will be there. So, there will be each subframe will have a word, each word is 12 bit and these bits are stored like this. So, you can actually store, we have given example of one of the word subframe 1, you can store in multiple bit like flight number, date, time in, then you can actually show the aircraft identifications. So, once you decode you get all the data like this in Neo software. And there is a this is a CVR part of it, this is a multiple channel, this is 128 bit kbps data. So, there you can actually do a signal processing, you need to do a signal processing and anomaly clustering and bring out the actual data which is valid, because there will be a lot of noises in case of audio data and you need to remove noise from the audio to bring the actual data for analysis. And this is shown some of the configurations which just open source you can actually see, and it generates a report like this, how many events happens, what is the percentage, how many live, final approach, which is useful for a user. And this is just a software logic how to develop, just one example for you. So, as today's technology, a new technology emerged which is called automatic deployable flight recorder. That means it is once the aircraft impacts, this recorder will be thrown out of the, it is not FDR, it will be thrown out of the aircraft and that will be tracked via satellite. So, this mainly came after the Malaysian air accident which was non-traceable for so many months. So, this is used today, this is a proposed and this is getting proposed in multiple aircraft, maybe another 10 years you will see in every aircraft they are trying to do this. And so, the conclusion of this presentation is flight data analysis is very important and very advanced field. So, the understanding of flight operations is required to properly understand an event. If you want to understand an event, you should know the dynamics, the physics, the operations behind it, and machine learning AI plays an important role for this flight data analysis in a performance scenario. So, an animated display like a FOA kind of software gives us quite a comprehensive view where you can actually feel what has actually happened, and it is a very exciting view for new engineers, students, scientists. You can try out, you can go ahead, you can see all the events. I think that closes my presentations. Thank you.
Great, Menak. We were mesmerized and loving listening to you. Great presentation indeed. We are receiving questions through different modes, through emails, YouTube channel, etc. So, friends, FOCA which Dr. Saab was using regularly is nothing but he said it in the beginning itself, just for the completeness I am repeating it, flight operational quality assurance. This is something like BIS marks on the aircraft mechanisms. So, we learnt a lot today through this technology. What are these? You took us to 1960s where the metallic Morse-key kind of data storage systems on metal sheets, which you call foil oscilloscope systems, and then you came to the tape, magnetic tapes, etc., where the magnetic fields were used, electric and magnetic fields were used to store the data, like we were using in our childhood and our cassettes, audio cassettes or so. And then the digital one. So I suggest Tanvi to start the question hour, question session.
Thank you. Firstly, I would like to thank you, sir, for the wonderful presentation. And yes, we did learn a lot of things through your presentation. And in the second last slide that you were mentioning about the Malaysian Airlines
Yes.
MH370. It's a
Yes.
very famous incident that we have all heard. And you said that something new is you trying to put so that the airlines could be located if in case such an incident happens in future. So about that, when an accident happens, an aircraft accident happens, and it gets into the water, and firstly it gets disappeared, then there are theories that gets emerged, either maybe it got drowned, or maybe it went to Bermuda Triangle when they get missing. So in that case, the black box helps, and the authorities can detect it, and the data still gets recorded even when the black box is inside the water for a long time.
Okay, great questions. I think this was one of the questions I also had when we started.
Yes.
So what happens actually, aircraft will have an FDR, right?
Right.
So aircraft gets into a crash. So after power removal, within 10 minutes, the aircraft actually stops, the FDR stops recording. That is a mechanism built into it. Otherwise, there will be endless recording, so which will overwrite the thing. So within 10 minutes, the recording will be stopped. So let's say it goes inside water. There is a beacon. This is called underwater locator beacon. It starts emitting once the impact happens to the water, and that is traceable. There is something called a corpus search satellite, like a GPS search and rescue network all over the world, which is validated. Every agency participate. An aircraft also has an equipment called ELT, emergency locator. That's a separate, but this starts a beacon. That beacon can be traced, but the only issue is that beacon is up to 20,000 feet only you can do. If it goes underwater 20,000 feet, it cannot be traceable. So if it falls into a region where it goes out of the down, then you cannot find that black box.
So did that happen with the MH370?
There are 2-3 theories, and there are some controversial theories. So in this platform, I don't want to talk into it, but there are some theories happen that there was an accidental transponder switch off, and because this network, what traced, it is a very big network, satellites, and the signals are very feeble. So there is an internal battery which does this. The battery died off after some time. So there are different theories. So I am just telling one of it.
Now at this point, I have some certain queries. You said 25,000 feet. It was nearly fairly good 7 kilometers or so. 7 kilometers, the Marina Trench is
20,000. That is unobstructed 20,000 feet. So once happens, you are, so let's say that trench, you are going, the signals gets like this. You cannot. There also 20,000 will not work.
Okay.
It has to be reduced. But if you are unobstructed, nothing is there after 20,000.
No, after 2,000 feet or so, that is unobstructed mainly.
No, suppose there are some trenches inside underwater where
so
the fall into it. Then there will be a
if you are in the
disturbance.
ridge area underwater,
Yes,
which
yes,
was tense. Yes, I understand the problem, or probably I understand my.
So that is why they are
audience
bringing
also
up this technology. This is
ADFR.
called ADFR.
No, so the point is, see, we are science students. हम लोग सपने बहुत देखते हैं, वो हमारा काम है. सपने देखेंगे तभी बात आगे बढ़ेगी. Like we have GPS systems in vehicles on surface transports, you mentioned that we can have a GPS chip in these black boxes, which can work even after the time.
No, not GPS chip, sir.
I mean something analogous to that, which
Yes,
can work
yes,
into
yes.
that atmosphere,
Yes,
into that environment, having that much of pressure. See, if it goes, say, 10,000 feet below, so how much of the hydrostatic pressure? Point is probably which you made here is that battery problem, how to keep the system charged.
No, that is there. I'll just explain you in a little regard. Now what is happening, this is ADFR, there is one new technology which I have not talked,
Okay.
is there. What is happening right now, still we are thinking of black box only will give the data after recovery. So at today's world, the next generation research is how to transmit online always.
Yes, this is
Okay.
Yes.
Okay, so what is happening, the present research and people are trying to employ is once you record data through data link, you pump out the data to all satellites. So you will always have a latest data available if aircraft also not there.
Means I mean what you are trying to say, आप जो कहना चाह रहे हैं शायद उसको मैं सादा सी भाषा में कहूँ कि जैसे ही डाटा ऑनलाइन अभी आपने बताया, इस समय वो हर आधे घंटे के बाद वो डाटा ग्राउंड स्टेशन को भेजता है और ग्राउंड स्टेशन
एक्चुअली सर FDR रिकॉर्डर का जो डेटा है वो डेटा एक्चुअली आपको रिकवरी आफ्टर रिकवरी ओनली आपको मिलेगा।
नहीं, आपने पीछे बताया था कि मुझे प्लीज करेक्ट मी इफ आई एम रॉन्ग कि फ्लाइट में डाटा चल रहा है और उसमें उसका मेमोरी है आधे घंटे का रफली और उसके ऊपर ओवरराइट करता है।
नहीं, वो नहीं कर सकता, और इनलाइन डेटा ट्रांसफर अभी तक एफडीआर में होता नहीं है, दैट इज फॉर अ सेफ्टी रीजन नॉट अलाउड।
ओके ओके ओके। सो व्हाट इट सेंड्स टू द ग्राउंड स्टेशन आफ्टर
is not sent by this, it is done by data link, it is a different kind of data,
Okay, okay.
not the flight data.
Not the flight data. Okay, okay, okay. So that is managed by with the international airport agencies,
yes,
etc.
yes,
etc. I can understand it. So well, if we do that, so the aircrafts will be uplinked or connected through the satellite links or through different microwave links or whatsoever is possible at that height, particular height, and then it is planned to go online, almost online. So when it touches the water, say is mentioned that it will, or when it attains a high jerk or pressure onto it, after that up till 10 more minutes.
Yes, it will be stopped.
After 10 minutes it will be stopped. So in that case, so we will be, the person managing the data, if it can be transmitted online. Correct. Immediately within a fraction of second.
Correct.
It will reach. So the rescue operations can also be made simple.
Exactly.
And rescue operations, it's not only the aircraft but the lives are also there.
There is also something called ELT, emergency locator transmitter in an aircraft.
Yes.
So what happens, it does two different frequencies, 121.1 and 406 not megahertz, which is also tracked by the satellite.
Yes, those
so you can actually find an aircraft.
What you mentioned about the Mangalore, there is a tabletop airport and there was rain and then it got skid down and then went down into the well and therein.
It was not able to understand the strip length.
Yes, I had seen that site. So were we able to get the FDRs?
It is the transcript. What has happened is all available in open source. You can actually go and read. Very interesting. So each one tells a different story.
Please tell us about. There is another catastrophe took place near Delhi in 2002 or so 2003, Charki Dadri accident. We had two aircrafts which were flying at different altitudes and somehow there was some mismatch in listening the signal from the air traffic control and they collide.
Correct.
What exactly
happened? So that is actually, if you see that particular, I exactly cannot remember the incident what happened, but if you see the report you will understand. But to avoid that, there is a new technology came which is called TCAS, Traffic Collision Avoidance Systems, which the aircraft to aircraft talks to each other. And if you are near to that, automatically your symbol will come in front of that aircraft is nearby. You please take, so automatically they will tell you take to this flight level, you take to this flight level. You will never, they will not allow you to collide each other. Okay. That is prevented by, that is the safety guideline.
I heard, I am not sure, you can tell us more better because there are automatic mechanisms.
Yes.
I mean a lot of confusion takes place when the pilots are from different origins and they do not understand, often they do not understand the languages or the accent of talking. Exactly this is what has happened in this Charki Dadri. We have got some more interesting questions. Please,
sir, regarding the accidents only, if we talk about let's say a plane has disappeared or let's say met with an accident, so whose investigation agency would be responsible to make the investigation? Let's say about the Malaysian Airlines, it was from Kuala Lumpur to China, right? So which authority? Every country has their own investigation agency.
First of all, there are two things. One is national borders, what is international border.
Okay.
If there is an international border, there is a joint treaty available between all the agencies. There is a joint team which internationally work and there is a ICAO team. So all spaced together will investigate first. They will be the primary authority, which is if it happens the international border.
How many nautical miles?
Which one, sir?
For the international border, suppose India has a border and then...
Indian Ocean is international water.
No, Indian Ocean is the international water. But
so I think it's
20 nautical miles? Or
not 20. It is like Andaman, it is 80 to 100.
Nautical miles.
After that international border starts.
Friends, let me make it clear. I mean, often we do not understand what the nautical mile is. The nautical mile is the distance, is a circular distance. Suppose this is the earth globe and you take it from the center and reach to the one point and the difference between these two, if this angle is 1 minute, So then this distance is called 1 nautical mile. So 1 nautical mile is different in kilometers, as we see in surface, is different on the surface of the earth, and is different if you go 400 kilometers from the surface of the earth, or even if you are 1000 kilometers below the surface of the earth. So nautical mile should be considered very seriously and differently, please. I mean that I just happened to explain what the nautical mile is, because children often gets confused with that it is 1.76 kilometer or so. It's not exactly everywhere. There are some more questions.
Yes,
I have
yes.
some more.
We both have a lot of questions to ask.
But important
yes.
questions I have. You can ask some simpler one first.
So all the aircrafts have these black boxes,
Yes,
be
mandatory.
it the passenger aircrafts or the defense aircrafts.
Passenger aircraft's black boxes is governed by the civil ICAO law and this federal law, FAR 23, FAR 25, this kind of laws.
Okay.
Whereas the civil, the military recorders, it is governed by a particular country of their own, their agencies. Like
Okay.
in India case, it will be CEBELAC.
Okay.
Okay, so that data DGCA cannot take out and read.
Okay, the concerned agency.
Because it contains confidential data. So the authorities, if you want to crash, they have their own investigation authority, military. So they will take out and do it.
Well,
Air
please
Force have-
come to slide 14.
Yes.
So we have last couple of minutes left.
Yes, I have to. Where exactly the FDR is located in this aircraft?
It's actually after this is a purely shown, not here, so then I will show you a different
Okay.
image. Here. See, this is the passenger backside door, which is a cargo door. You can see here. It's a cargo. Passenger sits before this, much before this. This is a cargo hold. After this area, this is unpressurized area, always.
Okay.
And here will be lot of stringers. Here you will have CVR and FDR pressure. This is taken as one of the safest
So
zone in air.
CVRs are not in cockpit.
No, there is
geographically.
that's what there is a confusion. If you have a CVR FDR separate, both you can keep it here.
I see.
What happens? There was some 1-2 incident. International it is not the rule. Only for India there is a rule that if you have a combi recorder, combi means if you have a CVR FDR in a single, then one has to be here, one has to be in the front.
One last question, which is coming to my mind for a very long rather. The noise in signal is always a problem.
Yes.
You are an electronics and telecommunication engineer first. So how to remove the noise, because noise is also a signal for telecommunication engineers
Exactly.
and for the signal processing. Can you tell us some simple mathematical principles that on what basis the sounds are being differentiated, because often the crew members advise, this is what we have read. I have never happened to be in an aircraft which is going to be.
Sure.
So what happens is that they say that you keep on speaking whatsoever you want to speak. Either you talk about the incident, or you can, if you like to speak something to your parents, something to your children, something to your friends, you keep on speaking. So they are advised like this. Then how the data is being managed?
Yes, I think that's a great question, sir. I think we also would like to tell little bit over it.
Yes,
see,
please.
let's say there is a CVR audio analysis. Okay, so 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 there are two kind of sounds. Let's say normal sound, and let's say sound. So always pilots will come, the cockpit will have a lot of static sound. So the audio speech gets embedded with the noise, and you have to actually recover the same this data. So get the actual profile of the what pilot, co-pilot, others are speaking. So let's say left side we have given original sound and sound without noise. This is the actual speech data, but we had a lot of sound due to static. So that to be removed. This is the domain of called signal processing, which is little advanced. That's why initially I have not brought for the students. So this is mainly done by a Fourier, which actually told that you can decompose this time domain signal into multiple frequency domain signals. That frequency domain signal you can compose, you can find the frequency component. So, 5 seconds of audio samples will have a 2,20,500 point if you do a Fourier transform. So, you have shown here 4, another 2,496 signals to be mapped and do it again. So, what we do normally, we do the analog to digital conversion, we do the digital signal processing, we clean the audio signals to analog conversion and we reconstruct. In between all this feature extraction, noise removal, audio search, audio database and speaker recognition happens.
Okay, that's great, that's great. We could get some data. See, this is, friends, be inspired that mathematics is very important for this kind of data work. And thank you once again. Thank you, Tanvi.
Thank you. Thank you so much, sir, for being with us today.
Thank you.
And the information you gave actually was relevant, important and interesting, because we are generally very curious about what happens in that aircraft when anything gets crashed or disappeared or any such incident. We don't want that, of course, but they do happen. And thank you so much for all this information, and we have got great response for this entire presentation. So thank you.
Thank you very much. Thank you.
And sir,
Friends, on 8th, we are coming back to you again. Today we had a session on aircraft, black boxes. As we promised you that, and on your demand itself, we had planned a session on bioinformatics. So we are coming back to you on 8th of December at the same time, 10 o'clock in the morning to 11 o'clock, where we will be having Dr. Narinder with us. He is in the Department of Geology, University of Delhi. He will be talking about some basics, कुछ मूल बातें बायो जैव सूचना विज्ञान या बायो इन्फॉर्मेटिक्स, उसके विकास और आगे की राह, आगे कैसे चलेंगे. So be with us, please be with us for an interesting session again on 8th of December. Happy Diwali to all of you.
Thank you. Thank you so much, sir.
Thank you.
Happy
Happy
Diwali
Diwali
to you too as well, and happy Diwali to all our viewers as well. Thank you so much to all the viewers for being with us today. I really hope that you loved this information, you loved this entire program. If in case you have missed watching this program, please watch it on NCERT Official, that is our YouTube channel. This was our 66th session on aircraft accidents and black box. And like Dr. Gagan Gupta announced, our next session is going to be on 8th of December. So please be here, and we'll be here sharp at 10 o'clock with that session. So thank you so much once again, and have a great day ahead. Before leaving, just want to remind you once again that NCERT textbooks for this new academic session 2023-2024, they're all available throughout the country. Either you can directly purchase them with the the sales counter, which are located in New Delhi, Bangalore, Kolkata, Guwahati and Ahmedabad, and the timings are 9:30 to 6 p.m. If you simply want to sit at your home and place an order, you can do that with the help of the website, that is ncertbooks.ncert.gov.in. And if in case you want to just simply download the PDF version or the soft copy, you can do that with the help of the NCERT Diksha or ePathshala website or their mobile applications. So thank you so much once again. Please keep on watching eVidya channels, because we have a lot in store for you in this entire day on different subjects, on different topics. We have a lot of programs. So please watch them, and all the very best. Thank you so much. Have a great day. I'm Tanvi Khurana, and I'll take a leave of you. Namaskar.